Good morning, guys, and welcome to our lab for today. We will be going ahead and doing the actual procedure for what makes hard water hard. Okay, so as you guys can see, we have set up, we are prepared for all 6 solutions at one time. Anytime you can, you want to get everything out ahead of the game all at once, so that you can be way more efficient from the get-go versus having to trip over people trying to find materials at the last second, missing a reading that you really needed, things like that. Okay, the first thing we're going to start with is weighing our filter papers. So filter paper 1, okay, 1.16. Filter paper 2, let's make sure this is 0. .95. Filter paper 3. .93. Filter paper 4. .95. Filter paper 5. .94. Notice as I'm measuring each one, I'm putting it with the lab setup that it belongs to. And then filter paper number 6. .94. Having gotten all of our values to be around 0.94, 0.96, I'm going to remeasure filter paper 1. I have a feeling that even though I zeroed it out, it didn't zero properly, and I'd be correct. So filter paper 1's correct mass, 0.94. Okay, so we have measured out our samples. We're only going to run one trial each, just in the interest of time. Okay, so I'm going to go by and I'm going to show you the graduated cylinders for each sample. Sample 1. Okay. Sample 2. Okay. Sample 3. If you see me tapping, I'm trying to get some of these air bubbles out. They're not our friends. So, sample 3. Sample 4. Sample 5. And do recall, this is recorded, so if you need to pause to get a reading, feel free. So sample 5. And last but not least, sample 6. Okay. So our next step is to measure out approximately 20 mils of our 5.5 molar sodium carbonate solution. Okay, so for each setup, I have a beaker numbered with the number of the sample, and I have I've taken some of my sodium carbonate and put it into a small beaker. We're going to measure out approximately 20 mils of the sodium carbonate and place it into the reaction vessel. So our first sample, I'm trying to get it so you can read it fairly clearly. Okay. So that's for reaction 1, and I just put it into the reaction vessel. Then I come along to 2. Trying to find just the right lighting. All right, so we're a little over, but that's okay as long as we know exactly how much there is. Okay, going to 3. Obviously, you guys can see one of the reasons we prefer glassware to plasticware in the chem lab. Unfortunately, that's not what we typically have here. So the plastic is a little bit harder to read. Get that bubble to pop. Okay. So that's number 4. Coming into number 5. Number 5. Again, just take your readings the best you can. That's all we can do in this situation. Okay, and last but not least, number 6. Okay. So we have our amounts of both of our substances. So now we can go ahead and mix them. So again, we've already recorded the volume of number 1, and we have the volume of number 2. We're going to put them together. Give them a swirl and let it sit for a moment. We'll do this with each sample. Again, we had number 2. Number 3. Number 4. Number 5. So you can definitely tell some have more and less just by the opacity of the resultant solution. And number 6. Okay, so while they react for just a moment, I'm going to get our filter papers put into our funnels. Okay, so we have our filter papers in. They've been wetted so that they fit the sides properly. So to filter out number 1, again, we're going to give it a nice swirl to try to get as much of the precipitate into solution as we can. And pour out, making sure not to go above the top. Okay, so there's 1. Two. 3. And we are being careful not to go above or to the sides of the filter paper. 4. 5. 6. and 6. And as you could see, probably there's just a tiny bit left in a couple of our beakers, like some on the sides. So once a decent portion of the solution has gone through the filter, we'll go ahead and rinse that into there to make sure we're getting all of our product in there. Okay, so we're about to filter this out. So again, we want to hold this kind of upside down and squirt the water up into the beaker. Let gravity pull the water and the rest of the solid out. Okay. So now this is nice and clean. We'll do the same for all of our remaining. Unknowns, get out as much as we can. Might not be perfect, but it's better than what we left off. We don't want to leave any more in here than we have to. So again, I'm just using a little DI water since that was our solvent to begin with. It won't affect any of the stoichiometric relationships. Again, I am making sure that none of the water goes around the sides of the filter papers. Okay, so now we just need to sit and wait for a little bit for these to filter. Once they're done, we can check our filtrate to make sure that all of the calcium has actually been collected by just adding a drop or two more of the sodium carbonate, making sure that no more precipitate forms. As long as it hasn't, we'll know that we're ready to move forward. So like I mentioned, now that the majority, or if not all, of our liquid is drained off, I'm going to take the reaction, the remaining liquid, and we're going to add approximately 5 more mils of solution to each one. So for number 1, I noticed with number 1, when I added 5 more, I definitely got some more precipitate, okay? So I'm going to take the rinsed vessel as my cleaning vessel. I'm going to go ahead and filter this. And obviously now we have a little bit more liquid than originally. So it's going to take a little bit more space, take a little longer to go through. Okay, so for sample 2, again, I know this is not the ideal way to measure. There we go. I can get creative, I think. Maybe not. Okay, so for sample 2, see your volume. Okay. Sample 2. There was a tiny bit of clouding, but really not much. So we can be confident that we will have collected all of our calcium with this filtration. We'll need to revisit number 1 because there was such a reaction. And we'll come back to this. Okay. For number 3. note minimal, if any, reaction at all. So again, for number 3, we're fairly confident that once we filter this, we are done with 3. So I'm going to put these while I have to finish filtering that. Once they're done being filtered, if I know we're pretty confident that we have them all, I'm going to remove this second beaker from the equation. Number 4. Hopefully we can read that. No notable reaction again. Again, I will show you for your own observations. For number 5. Again, we have no notable reaction. And last but not least, we'll take care of number 6. That was just a smidge, too much. Okay. And for number 6. Okay. Again, I thoroughly agree that plastic graduated cylinders are not ideal for analytical pursuits, but it's what we have. And we can see number 6, just like number 1, has some more significant precipitate. So we'll definitely have to add another 5 to both 1 and 6. I'm just going to come back down the line. Try to see if we can't fit the rest of each of these liquids. So again, that one's done. That one's done. That one's done. That one's done. Number 1, not so much. And we're going to have to add just a little more to this. So I got some water. Watch glass. So again, 1 and 6, we're going to have to add a little more. Make sure that we've gotten all the calcium out of solution. So we'll just go in 5 milliliter increments until we see no reaction in the vessel for the filtrate. And again, it's not going to be exactly 5 milliliter increments, but in that general range, as long as we keep track of the total amount of sodium carbonate added, stoichiometrically, we can still figure out how much of the carbonate, or the calcium, I'm sorry, was actually in our water samples. Okay, so we're going to add another 5 mils to our number 1, or roughly 5 mils. So this would be the volume we will be adding. Okay. We still have a measurable or observable amount formed. We don't get quite as opaque, but we're definitely getting highly cloudy. So after this one, we'll do at least another 5 until we see no observable reaction. Okay, so we're ready to add another 5 to solution 6. So if you can read that. Okay. Just like 1, we do get some reaction. So we're gonna have to go at least 1 more time. This one's actually still pretty thick. Solution 1 is ready for another 5 mils to see if we actually still get precipitate. So let's go ahead and do that as well. Number 1 is filtering the best out of all of these, which is fine. This is definitely a waiting process, which you guys are not experiencing being at home and the powerful video editing. So this is going into solution 1. Okay. And we're just gonna see, do we get a reaction? And it is nothing observable. So we are done. This is our last filter for number 1. Okay, as these ones are finished, we can now remove these and put them on our watch glass so that they're ready to go into the oven. Each of my watch glasses has been labeled with a sample number on it, so I can keep track of them once they're out of the oven. Okay, so we're going to very gently, being careful not to touch the inside of the filter paper, remove them, and unfold. Really hard not to touch the inside, because that's where we might get some of the product on our fingers, which would then affect our yield. So same with number 3. The part of the paper I am touching is the part that was folded, and so it never came in contact with the sample itself. So kind of when I reach for it, I'm reaching for that folded little flap. I'm reaching for this folded little flap that was kind of outside of the filtering process. Got 2 through 5 out and starting to dry. I can actually go ahead and put these in the oven. The oven is right next to the fume hood over there. It's currently set to approximately 105 degrees Celsius, which is important because that's just over the boiling point of water. And so it'll drive off any water that we have, but still not be dangerous as far as like catching anything on fire. So we're going to arrange these in the oven so that they're not touching one another and they can all dry out. While we wait for numbers 1 and 6 to finish filtering, I do want to just note that our samples were not boiled down. So when you do your calculations, you don't need to account for concentrating the solutions down to that 200%. So whatever calculation, whatever math you do, it's going to be the exact actual part per million, or I'm sorry, your grams per liter. So you don't have to do that extra step. So once one finishes up, this one will go into the oven as well. And once 6 is done, this filtering, we have at least one more addition of our sodium carbonate to ensure that the reaction is complete. Okay, so we're ready to do what we hope is our final addition to our 7th sample. As you notice, just good housekeeping. All of our other samples are in the oven, so I've cleaned up their apparatus so that I only have out what I need to have out at any given time. Reduce the risk for breaking things, dropping things, mixing things up, all of that. So our final measurement, hopefully, we'll see, for number 6. Okay. So let's see if we get any reaction. Okay, no discernible reaction, so we'll filter this one last time and then get this in the oven as well to dry. Once things are dry, we'll get our initial dried masses for all of our substances, put everything back in the oven for a few minutes, and then make sure that we're at constant weight. Once we've achieved that, our lab is complete. Okay, so our first dryings are done and our samples are cool. It's extremely important to make sure that your samples have cooled before you find the weight. Otherwise, you're going to experience significant drift due to the air currents. Okay, so sample 1 has a mass of 2.20. Sample 2, and we'll make sure this is zeroed out fully. 1.33. Sample 3. 1.78. Sample 4. Okay. And sample 5. Sample 6 is still in the oven. In fact, it just went in there. You're welcome. I'm not making you watch everything dry. So again, this is sample 5. Okay, we're going to put all of these back into the oven for a few minutes and take them back out, let them cool again, and then just make sure that we are at roughly constant weight. Okay, so we're ready to get our first measurement for number 6. Get that drift out of here. And we get, there we go. So I have all of the others after their second drying. So we'll put number 6 back in so we can get constant mass, and we'll check all the others to make sure we're there. So we'll start with number 5. We'll just work our way down. So we're at 0, 0, 0. Last time we were within 0.01 grams of this, so this is constant weight, so you're good to go. So sample 5. Sample 4. Again, within 0.01, 0.02 grams, so this is acceptable. If the drift stops. Come on, drifting. Again, if you don't remember from last year, drift is going to be a result of air currents, pressures, things like that around the balance. So you always want to be nice and still. There we go. All right, so 4 passes criteria. Let's look at 3. Again, we're at a nice even 0. Beautiful. Okay. Number 2. Perfect. And number 1. All right, so all of our original samples that we had already measured once pass our constant mass criteria. So those are done. Our data is done being collected. We'll put number 6 back into the oven. Okay, I'm going to make sure I'm grabbing the glass underneath. We don't ever want to, we have the paper on a watch glass. We don't ever want to put the paper directly in here by itself. Okay, so we're going to put this in here for just a couple of minutes, and then we'll remass it after it cools and see where we are. Second weigh of sample 6. Okay, and our drift is all over the place. So we've definitely lost a few tenths, but not significant enough to have to remeasure. So that's your first lab. Keep in mind that if we were in actual lab, like you were performing this, we would make sure that our lab station is nice and tidy when we're done. Everything is cleaned and put away, and that's it.